Your heating bill arrived last month. $200. The south wall of your house absorbs free solar energy every day from October through March. You have never captured any of it. A $50 panel on that wall pushes 140-degree air into your living room. No electricity, no moving parts. The HVAC industry has known this since 1881. They have spent 145 years making sure you never find out. The $50 fix, the exposed supply chain, the math they never wanted you to run, all of it buried and none of it complicated. You pay $2,400 a year to heat your home. Over 30 years, that is $72,000. Not on the house, not on the mortgage, on the heat inside the house. Most of it did not have to leave your bank account. Heat that the sun is delivering to your south-facing wall for free right now while you write that check. The residential heating industry in the United States generates over $120 billion a year. That number depends entirely on you not knowing that a sheet of polycarbonate, a layer of black mesh, and a hole in your wall can do what your furnace does for the 4 to 6 hours a day when the sun is out. What you pay each year is not the cost of heat, it is the cost of not knowing. And the man who first proved it was not an engineer, not an architect, not anyone the heating industry would consider a threat. He was a zoologist who studied seashells. In 1877, a zoologist named Edward Morse boarded a steamship bound for Japan. Morse was a professor at the Peabody Academy of Science in Salem, Massachusetts, a specialist in brachiopods, small-shelled sea creatures, that he could identify faster than most people can name a state capital. He had published extensively on invertebrate taxonomy. He was, by every conventional measure, a man whose professional life had nothing to do with buildings or heating or the way sunlight interacts with a south-facing wall. But Morse was also a compulsive observer. He drew constantly, he documented everything. And when he arrived in Japan and began traveling through the countryside, he noticed something that had nothing to do with shells. Japanese houses were oriented deliberately toward the sun. South-facing walls were built with dark surfaces and covered with translucent screens. In winter, the interior air near these walls was warm, noticeably, measurably warm, without any fire burning, without any fuel consumed. The sun hit the dark wall, the wall heated the trapped air, the heated air rose and circulated into the room. The Japanese had been doing this for centuries. The same heat your furnace charges you for every month. They had been collecting it for free with dark paint and paper screens. Morse went home to Salem with different questions than the ones he had arrived with. On April 5th, 1881, the United States Patent Office granted Edward Morse patent number 246,626 for a device he called a solar air heating apparatus. The design was straightforward. A glass covered the box mounted on the south wall of a building, with a dark absorber surface inside and vents at the top and bottom. A continuous convective loop powered entirely by the sun. It required no electricity, no fans, and no fuel of any kind. Not about shells, about heat. About the oldest energy source on the planet, captured in a wooden box with a piece of glass over it. The mechanism Morse patented is called a thermosiphon, and the physics of it could be explained to a child. Dark surfaces absorb sunlight and convert it to heat. Glass traps that heat by allowing visible light in, while blocking infrared radiation from escaping. Hot air is less dense than cold air, so it rises. If you create a path for the hot air to rise into the building and a path for cooler air to flow down into the collector to replace it, you get continuous circulation without any mechanical assistance. The temperature differential does all the work. Morse published his findings in academic journals. The patent expired after 17 years, as patents do. Morse went back to his brachiopods, and the solar air heater entered the public domain, free for anyone to build, improve, or manufacture. Free for anyone, and a threat to everyone selling the alternative. The question is not why Morse's idea failed. It never failed. The question is what arrived to replace it. Nothing replaced it. Nothing could. A single 4 by 8 foot solar air panel, the modern descendant of Morse's 1881 patent, still produces between 1,000 and 3,000 BTU per hour of thermal energy on a clear winter day. The air temperature at the output vent runs between 80 and 140 degrees Fahrenheit, hotter than what your furnace pushes through the ductwork you paid $3,000 to install. These are not laboratory numbers from a controlled environment. These are field measurements from panels operating in Minnesota, Wisconsin, Ontario, and Alberta in climates where winter temperatures drop to -20 and -40 degrees Fahrenheit. It works on cloudy days at reduced output, 30 to 50%, because infrared radiation penetrates cloud cover. It works in December when the sun is lowest, because a south-facing vertical panel is actually optimally angled for low winter sun. The geometry that seems like a disadvantage is the advantage. Your south wall in January is closer to perpendicular to the incoming sunlight than it is in July. Winter is when the panel works hardest. Hard enough that in the right conditions the furnace stops running entirely and the gas meter stops spinning. There is a variant that costs even less. Instead of aluminum screen, you fill the inside of the panel with crushed aluminum soda cans. The cans create turbulent airflow. The air spends more time in contact with more heated surface area than it would flowing across a flat screen. The result is higher output temperatures from a smaller panel using material that your neighbor was going to throw away. In 2014, a retired mechanic in Bemidji, Minnesota built exactly this kind of solar air heater on the south wall of his garage using materials he had in his shop and one trip to the hardware store. The absorber was crushed Budweiser cans from his neighbor's recycling bin, a detail he found amusing for a project built on a Saturday afternoon. The glazing was a 4x8 sheet of clear polycarbonate, $16 at the building supply. The frame was scrap lumber, the total cost was $37. He drilled a 4-inch intake hole near the bottom of his garage wall and a 4-inch output hole near the top. He mounted the panel, sealed the edges with silicone caulk, and waited for a sunny February morning. By 10:30, the output vent was pushing air at 131 degrees Fahrenheit. He measured it with a meat thermometer held against the vent, because he did not own a proper anemometer and did not see why he should need one. His gas bill for the garage dropped 40% that winter. The panel is still there. He has replaced nothing on it in 12 years. But what happens when something like this scales beyond a single garage wall? The same physics that heated a mechanic's garage in Bemidji for $37 scaled to Ford Motor Company. 200,000 square feet of south-facing wall on the Windsor Assembly Plant in Ontario. Then FedEx distribution centers across the northern United States. Then NASA at the Kennedy Space Center. Then the United States military at Fort Drum in upstate New York, where January temperatures reach -20 degrees Fahrenheit. And the Army's assessment classified the energy savings as a strategic advantage, not just an economic one. When your heating bill for a military installation drops by 30 to 40%, you are not just saving money. You are reducing your logistical dependency on fuel supply chains that an adversary can target. The product behind all of it is called Solar Wall. In 1992, a Canadian engineer named John Hollick began manufacturing it. A dark perforated metal cladding mounted on the south wall of a building, with a small air gap between the cladding and the wall. A low-power fan draws outside air through thousands of tiny perforations in the sun-heated metal. The preheated air is ducted into the building's ventilation system, reducing the load on the conventional heating plant. Conserval Engineering has completed more than 3,000 installations in 11 countries. Documented energy savings range from 20 to 50% of heating costs. Payback period, 2 to 7 years, depending on climate and fuel costs. After payback, the heating offset is free for the remaining life of the building, which for a metal panel with no moving parts is measured in decades. The residential version of this, the one you can build on a Saturday, costs less than your last electric bill. You have never heard of Solar Wall. Not because it failed. It has been working for over 30 years. On the walls of Fortune 500 companies, federal buildings, and military bases. You have never heard of it, because a technology that eliminates heating costs generates no recurring revenue for anyone in the supply chain. There is no filter to sell, no refrigerant to recharge, and no annual service contract to renew. No one whose income depends on SolarWall has any incentive to advertise it to you because the product works by making the next sale unnecessary. No recurring revenue, no industry advocate. But the pattern runs deeper than neglect. In 1967, at a solar research station in the French Pyrenees built to melt metal with concentrated sunlight, two men were asking a quieter question. Michel Trombe was a physicist. Jacques Michel was an architect. Neither cared about melting metal. They wanted to know if the same sun could heat a house. Trombe and Michel published the first modern engineering analysis of what is now called the Trombe wall. A south-facing mass wall painted dark, covered with glass, with vents at the top and bottom. In winter, the system functions as a solar air heater. Sunlight heats the mass heats the air circulates into the building through the vents. But the mass also stores heat, which is what makes it different from Morse's panel. A 12-inch concrete Trombe wall absorbs solar energy all day and releases it slowly through the evening and night, providing warmth for 8 to 12 hours after the sun sets. The panel heats your house while the sun is shining. The Trombe wall heats your house after the sun goes down. They documented that their glass-covered wall system met 30 to 45% of heating needs in a cold mountain climate at 6,000 feet elevation, where winter temperatures regularly dropped below 0 Fahrenheit. The results were funded by the French government, peer-reviewed, and replicated in 3 countries. In the United States, the 1973 oil crisis created a brief window of political will. Los Alamos National Laboratory launched a passive solar research program. Steve Baer, a self-taught solar engineer working out of Corrales, New Mexico, a man who had dropped out of UCLA and educated himself on thermodynamics by building things and measuring what happened, had already been constructing passive solar homes with water-filled drums stacked behind south-facing glass walls. The drums absorbed solar energy during the day and radiated it into the living space at night. A variant of the same principle Morse had patented and Trombe had quantified, arrived at independently by a man who had never read either of their papers. Doug Balcom, a physicist at Los Alamos, led a systematic study of passive solar heating across multiple climate zones and building types. The data confirmed what Morse, Trombe, Michel, and Baer had all independently demonstrated. A south-facing glazed collector, properly sized, could meet 30 to 70% of a building's heating needs with no fuel and no moving parts. The Department of Energy published the results. The research entered the federal record. Then Ronald Reagan took office. Federal solar research funding was cut by 89% between 1980 and 1985. The Los Alamos program was gutted. The tax credits for solar thermal systems expired. The second wave of American solar heating research collapsed in less than 5 years, dismantled not by failure, but by a change in who was writing the budget. The same playbook that had destroyed solar water heating a generation earlier. And we will get to that story next. The pattern by now should be familiar. A technology that works, documentation that proves it, and a moment where the industry that profits from your ignorance applies just enough pressure, not to ban it, but to erase it from every classroom, every building code, and every estimate your contractor has ever handed you. The suppression of solar air heating did not require a conspiracy. It required a supply chain. In the 1950s, natural gas pipelines reached every major American market. Gas utilities built contractor incentive programs, rebates, preferred supplier status, volume bonuses, that rewarded HVAC installers for recommending gas furnaces over every alternative. A plumber who recommended a solar air panel received a one-time installation fee for cutting 2 holes in a wall. A plumber who recommended a gas furnace received a rebate from the utility, a preferred supplier relationship with the equipment manufacturer, and a customer who would call him back for service, maintenance, and eventual replacement for the next 30 years. The financial math of that recommendation was never close. Trade schools, funded in part by equipment manufacturers, trained the next generation of technicians on gas and electric systems exclusively. No curriculum in any accredited American HVAC training program teaches solar air heating, not because it does not work, because the companies that fund the programs do not manufacture it. Building codes, written with substantial input from ASHRAE, the American Society of Heating, Refrigerating and Air Conditioning Engineers, established mechanical heating as the baseline assumption for every occupied building in the country. You can mount a solar air panel on your south wall tomorrow. The building code will still require you to have a furnace installed. Every link in that chain depends on you believing that mechanical heating is the only serious answer to a cold house in January. The pipeline delivers the gas. The contractor installs the furnace. The code requires the mechanical system. The trade school trains the technician who services it. ASHRAE writes the standard that the code references. And ASHRAE's funding sources are public record. The companies that manufacture furnaces and ductwork sit on its technical committees. This is not hidden, it is simply not discussed in the classes where those standards are taught as neutral and inevitable. No manufacturer lobby exists for solar air panels. No trade association funds research on a $50 device built from hardware store materials. No contractor earns a recurring service revenue stream from a box with no moving parts. The absence of advocacy is the suppression. An industry built on monthly payments cannot survive a product that eliminates monthly payments, and it does not need to ban that product. It only needs to make sure the product is never mentioned in the training, never referenced in the code, and never recommended by the person standing in your kitchen giving you an estimate. So here is what happens when you skip the estimate, walk outside and stand in front of your south wall in January. It is January. You are standing outside your house on the south side. The wall faces the sun. You press your palm flat against the siding just below the second floor window and the surface is warm. Not the ambient temperature of the winter air around you, which is 28 degrees Fahrenheit and biting at the skin on your wrists above your gloves. The wall is warm because the sun has been hitting it since 8:30 this morning and it is now noon, and the thermal energy has been accumulating on this surface for 4 hours, radiating back into the sky, heating nothing, serving no one, wasted. While inside the house the furnace has been running since 6 in the morning, and the gas meter has been spinning, and the bill has been building at $4.62 per therm. Look at the wall. The siding is faded where the sun hits hardest, a rectangle of lighter paint between the windows where decades of ultraviolet exposure have bleached the color out. That bleaching is evidence. It is the record of energy that hit this wall every winter day for 20 or 30 years and was converted to nothing useful. The sun gave your wall that energy for free, and the wall radiated it back into the atmosphere, and you went inside and paid the gas company for the same thermal service. You can hear the furnace blower through the wall if you stand close enough. A low hum, steady, the sound of money leaving. The gas that feeds it traveled through a pipeline from a processing plant that bought it from a wellhead in Pennsylvania or Texas. Every therm that enters your house passed through a supply chain with a margin at every stage. The wellhead owner, the pipeline operator, the processing facility, the local utility, the contractor who installed the furnace, the manufacturer who built it with a 15-year lifespan, so you would buy another one. Each of them earns a fraction of your $4.62 per therm, and each of them needs you to keep paying it. Now mount the panel, a 4x8 sheet of twin-wall polycarbonate, a frame of pine 1x4s screwed together at the corners. Black aluminum window screen stretched taut across the interior cavity as the absorber surface. 2 4-inch holes drilled through the wall, one near the floor and one near the ceiling, with short lengths of duct pipe connecting the panel cavity to the interior of the house. Silicone sealant around every edge. A small backdraft damper on the lower intake, a $3 plastic flap that closes by gravity when the sun is not heating the panel, preventing cold air from flowing backward into the house at night. Total materials cost $50. Build time, 1 afternoon. The sun hits the polycarbonate at 8:45. The light passes through the glazing and strikes the black screen. The screen absorbs the solar radiation and converts it to heat. The air between the screen and the wall begins to warm. Within minutes, the heated air is rising toward the upper vent, and cooler room air is being drawn in through the lower vent to replace it. The convective loop that Edward Morse patented in 1881 is running on your wall in your house powered by nothing but the temperature difference between sunlight and shade for the first time. By 9:30, the thermometer at the output vent reads 80 degrees. By 10, it reads 100. By 10:45, it reads 112. By noon, 120. You hold your hand over the upper vent and feel it. A steady stream of air, warm enough that you pull your hand back for a moment because you are not expecting it to be that warm. The air pushing through that 4-inch hole in your wall is hotter than the air coming out of your furnace duct across the room. You stand there and listen. The furnace has not fired in 2 hours. The gas meter outside has not moved. The house is the same temperature it was at 10 o'clock and no fuel has been consumed to maintain it. The math arrives whether you want it or not. One panel offsets 15 to 25% of your daily heating load on a sunny winter day. A full south wall, 4 to 6 panels depending on wall size and window placement, offsets 50 to 70%. Materials cost for a full installation, $200 to $300. You do not need a professional installer, a permit in most jurisdictions, an electrical connection or a gas line. There is no maintenance schedule and nothing to service. The only component with a lifespan is the polycarbonate glazing, which in the current generation of UV stabilized materials lasts 20 to 25 years. At which point you replace a $16 sheet of plastic. Now run the numbers they never wanted you to run. Conventional heating over 30 years in the average American home. $60,000 to $90,000 in combined fuel costs, equipment purchase, equipment replacement and service calls. The furnace itself costs $3,000 to $8,000 and lasts 15 to 20 years, so you will buy 2 or 3 of them. The gas bill runs $1,500 to $3,000 a year depending on your climate and your home's efficiency. The service calls run $200 to $400 each, and the technician will tell you the heat exchanger is cracking and you need a new unit. And he's probably telling the truth, because the manufacturer designed it to last exactly long enough to be out of warranty when it fails. Solar air panel installation on that same home, $200 to $300 once. Lifetime savings, $30,000 to $63,000. Stand there with that number, $63,000. That is a child's college tuition. That is 3 years of retirement savings. That is the down payment on the second property you decided you could not afford. And it has been sitting on your south wall, radiating into the winter sky since the day you moved in. Your heating bill is not a cost of living. It is someone else's business model built on the assumption that you would never hold a piece of polycarbonate against your south wall and notice that the air behind it was hotter than the air coming out of your furnace. The sun has been hitting your south wall since before the house was built. Edward Morse patented the device to capture it in 1881. French physicists proved it in a mountain winter. Los Alamos confirmed it across every American climate zone. A Canadian engineer scaled it to Ford assembly plants and military bases in 11 countries. And a retired mechanic in Bemidji, Minnesota built one for $37 out of beer cans and a sheet of polycarbonate. And dropped his gas bill by 40% in the first winter. 145 years of documentation, 5 independent lines of research on 3 continents, exposed to sunlight and still working everywhere it has ever been installed, because the physics has not changed since 1881 and will not change tomorrow. The knowledge was never lost. It was set aside by an industry that could not find a way to bill you monthly for sunlight passing through glass. Your south wall is already warm. It has been warm every clear day of every winter you have lived in that house. 145 years after a zoologist came home from Japan with a drawing and a question, the only thing that has changed is that the polycarbonate is cheaper, the science is more documented, and the furnace industry is larger. The sun has not changed. The wall has not changed. The only question is whether the heat it absorbs keeps radiating into the sky or starts flowing into your living room. $50 answers that question permanently. The sun heats your air for free. It also heats all your water for free. A black pipe and a tank, that is all it takes. 1 million American homes ran on solar water heating before the gas industry spent a decade erasing it from memory. The system costs less than your current water heater, lasts twice as long, and has no monthly bill attached to it. That archive is already open. Click it now.